Hey guys, I'm Andrew from Lampro Event Solutions. Welcome to our second online sound training session that will be discussing the sound system, specifically focusing on input transducers, mainly microphones. Please remember to follow us on Facebook and to subscribe to our YouTube channel to receive updates for all the future sessions that will be coming up. If you already subscribed to our YouTube channel, hit the notification bell to receive notifications about our latest videos. Before we get going, I'd like to do a short intro about my company. Lampro Event Solutions specializes in technical services for the events industry, and we're a supplier and installer of professional sound, lighting, AV, and staging equipment. If you need any of these services, please send me a message or leave a comment below, or visit our website at www.lamproaudio.co.za. We make use of a number of professional brands that include Turbo Sound speakers, Allen & Heath's digital and analog mixing consoles, Audix, Sennheiser and Shure microphones, as well as other processors that include Radial Engineering and DBX. I also decided to add Behringer, Wharfedale and Samson into the mix. I briefly mentioned in our first session that some of the entry-level brands can be used very effectively to achieve professional results. It all comes down to the professionalism and experience of the sound engineer that's using it. If you guys are interested, I'd like to do a couple of videos that will review and compare some of the entry-level brands to the more expensive ones. You'll be pleasantly surprised by the outcome of these comparisons. I'll be referring to different examples of Shure, Sennheiser and Audix microphones during the session. If you make use of AKG, Audio-Technica, Beyerdynamic, EV or any other mic brand, it's really not a problem. As always, the theory behind these sessions will be applicable to all makes and models of professional sound equipment. I quickly want to mention the references that I'll be using during the online sound training sessions. The most important reference is the Yamaha Sound Reinforcement Handbook. It's an old publication that was released approximately 30 years ago, but the theory in it covers all of the important aspects of live sound reinforcement. There are a couple of other references that I also use, all of which can be downloaded from the links that are included in the video description below. The second reference is the Soundcraft Guide to Mixing, which could be found on the Soundcraft website, which primarily focuses on mixing consoles and how to achieve a good sound mix. The third one is Microphone Techniques for Live Sound Reinforcement, which can be found at the Shure website, and that discusses all the different types of mics and how to use them effectively for live sound purposes. We'll be referring to this guide in this session. The third one is Loudspeaker Basics from electrovoice.com that will focus on different types of speakers and their applications. The fourth one is 10 key tips for better sound that can be found at behindthemixer.com. And then lastly, the Alto Pro Live Sound Guide that can be found on the Alto Professional website, which will give you a general explanation of sound from start to finish. Okay guys, so let's get going with the second session of the course, namely the sound system or sound chain. I briefly mentioned in the previous session that the sound chain falls under the category of electric energy, a process where acoustic energy or sound waves are converted into electric energy or electric audio signals. I'll be covering all the aspects of the sound chain in 4 different sessions. This one will cover input transducers, also known as microphones. The 2 sessions after this one will cover signal processors, focusing on mixing consoles and other processors, for example compressors, limiters and gates. In the 4th one, we'll discuss output transducers, also known as loudspeakers. A sound system consists of various types of components. These components all work together to create what we hear as sound. We can use a simple home theater system as an example. When a media source, such as a CD, USB or DVD is connected to the media player, different processes take place before we hear audible sound waves through the speakers. Transduction, preamplification, equalization and amplification takes place. We will be looking at a very basic professional sound system explaining all the components that is part of the sound chain. They are input transducers, signal processors, and output transducers. The following diagram illustrates the working of a typical sound chain. On the left, you can clearly see sound waves being picked up by different types of input transducers or microphones. These can be different types of microphones that are intended for different purposes. Once the mics convert the sound waves into electric audio signals, the mixer will pre-amplify and process the electric signal further by means of gain adjustment, equalization or EQ in short, and level control that is sent to the main outputs. From here, the audio signal can be processed further by means of compressors, gates, or effects processors. In the final stages, the audio signals will be amplified by power amplifiers before being sent to the loudspeakers, which converts the electric audio signals into sound waves once more. Now, it's important to mention that with some analog mixing consoles, but more generally with digital mixing consoles, a lot of the needed processing can be done before reaching the power amplifiers. Digital mixing consoles are the new standard, and they've been around for the last 20 years or more. The onboard processing makes them a lot easier to use, but prior to this, a lot of outboard or external processors were common practice when doing sound. Don't get me wrong, they are still available and can still be used to get specific results, but outboard processors including compressors, gates, limiters, and effects processors are not that common anymore. We'll go into this in more detail in the next session when we discuss mixing consoles. Okay, so let's have a look at input transducers more closely. Input transducers are devices that convert acoustical energy or sound waves into electrical energy. The most common type of input transducer that we'll be discussing is the microphone. Microphones are audio devices that are used to convert all sources that produce sound by means of sound waves into an electric audio signal. Examples of such sources are voices, string instruments, and drums. There are basically two types of microphones with different components to convert incoming sound waves into electric audio signals. They are dynamic microphones and condenser microphones. Dynamic microphones are the most common type of all microphones because they are robust, cost-effective, and can handle high SPLs or sound pressure levels. Dynamic mics have a good frequency response depending on the overall quality of the mic. Some of the entry-level brands have a less accurate frequency response and is more susceptible to feedback. Handling noise also tends to be a problem. Always try to invest in good quality microphones to minimize potential problems in the long run. If the quality of your microphones are not up to scratch, the quality of your overall sound mix might be compromised. If you start with low quality sound at the input phase, that's most likely what you will also get out of your speakers. The frequency and transient response of dynamic microphones are not as good and accurate as condenser microphones, but they're still very effective for their intended purpose. Dynamic microphones are best suited for most vocal applications, as well as instruments that produce high SPLs, such as drums, brass instruments, and guitar amps. To this day, they remain the best suited microphone for most applications in live sound reinforcement. As seen on the following illustration, a dynamic microphone's capsule is made from the following components, namely the diaphragm, voice coil, and magnet. I'll show you some examples of these shortly. The different components work as follows. Sound waves are picked up by the diaphragm of the microphone. This will cause the diaphragm to start vibrating, which in turn will cause the voice coil to move in a similar fashion. These vibrations are picked up by the magnet and is converted into an electric audio signal. This is also known as the process of transduction. A microphone's pickup field above the diaphragm is also known as the polar pattern of the mic. We'll get into different types of polar patterns once we've covered the different types of microphones. Okay guys, I'm quickly going to show you a practical example of a dynamic microphone. I'm sure that most of you are familiar with the Shure SM58. This is a good quality dynamic microphone for vocal applications that's widely used in live sound reinforcement. If we remove the protective grill at the top, this will give you an idea of what the capsule looks like. And inside you've got the diaphragm, voice coil, and magnet. And what basically happens, as it was shown on the illustration before, Sound waves will enter the on-axis point of the microphone. The diaphragm will start vibrating, which in turn will also cause the voice coil to move inside, and the magnet will then convert the sound waves into an electric audio signal. So we've had a look at that, and then other examples of dynamic microphones, which I'll also show to you on a slide. I mean, this is very similar to the SM58. It's a SM57 that's used for instruments specifically, but it's also a dynamic microphone. And then you've got various other examples of instrument mics that are also dynamic microphones. All of these are dynamic microphones that are used for drums, the Audix F6 and the Audix F2. And then we also have one that's very similar to the SM57 called the Audix i5. And all of these are examples of dynamic microphones. Okay guys, I just want to show you a few more examples of dynamic microphones. On the left you have the Shure SM58 and next to it the SM57 that was just shown to you. And as I mentioned, the SM58 is a well-known industry standard dynamic microphone that is used for vocal applications. Next to it is the SM57 that has the same characteristics as the SM58. The only difference is the grill of the microphone, since the SM57 is primarily used for instruments. The SM58 has a larger grill with foam lining inside, which makes it less susceptible to vocal popping and breathing noise. The Beta 58 and Beta 57 microphones are the same type of dynamic mics as their SM counterparts. The only difference is that they are manufactured from better quality components to produce better sound quality. Better sound quality equals a higher price tag. The next page includes more examples of dynamic mics, namely the Sennheiser E835, the Audix OM5 and the AKG D5, which are all vocal dynamic microphones. The Audix i5, which was also shown to you, is an instrument mic that is very similar to the Shure SM57. Here's some examples of drum microphones, namely the Audix FP7 and AKG Session 1 drum mic kits. They're commonly used on drum kits, but can be used on other percussion instruments as well. The only exception here is that these kits also include condenser microphones, which we'll get into next. Okay guys, let's quickly have a look at condenser microphones. Condenser microphones are considered to be the best when it comes to sound quality. They produce exceptional, detailed sound and have very good high frequency and transient response for superior clarity. There are a few things to consider when using condenser mics. They're a lot more sensitive and fragile than dynamic microphones. Their sensitivity tends to make them more susceptible to feedback, and they can't handle very high SPLs the same way that dynamic microphones can. This can cause unneeded distortion when they are placed very close to loud sound sources. High-quality condenser mics are also expensive, costing up to 4 times as much as good quality dynamic microphones. Condenser mics do, however, have their advantages. They are the #1 choice in recording studios for their superb sound quality. They're also very effective for picking up soft sound sources and sources that are far away from them, a feature that dynamic mics tend to lack. Condenser mics are used for various vocal applications, including solo vocalists and choirs. They're also useful for soft instruments, including stringed instruments like acoustic guitars and violins, wind instruments like flutes, and percussion, especially when placing them overhead to capture the sound from cymbals and the overall drum kit. As seen on the following illustration, a condenser microphone's capsule is made out of the following components, namely the diaphragm case, diaphragm, and back plate. The transduction process is very similar to that of a dynamic microphone, the main difference being that condensers make use of a back plate instead of a voice coil and magnet to convert sound waves into electric audio signals. Condenser capsules require an additional power source of 48 volts to work. This is also known as phantom power and is usually sent from the mixing console when it's been activated on a designated channel or on the mixing console as a whole. Okay guys, let's have a look at some examples of condenser microphones. On the left is a good example of a studio-grade condenser microphone known as the Shure KSM27. The KSM27 have selectable polar patterns, another feature of microphones that we'll discuss shortly. Next to it is the Shure SM81, a common instrument condenser mic that is used to mic up choirs, stringed instruments, percussion, and other soft instruments. The Shure KSM9 is a good quality vocal condenser mic that is ideal for live sound applications, as well as the Shure Beta 87 next to it. These vocal condenser mics usually make use of super or hypercardioid polar patterns or narrow pickup fields to pick up the sound directly from the source in front of it. On the second page, we have the Sennheiser E965, the Audix VX10, and the AKG C7 that is very similar to the Shure KSM9 and Beta 87 vocal mics. The Audix ADX51 is similar to the Shure SM81. Here's a video that will give you a good summary of all the topics that we've discussed so far, including the types of microphones and their different applications, courtesy of Shure Incorporated.
A microphone's primary purpose is to convert acoustic energy, sound, into electrical energy, a signal that can be amplified, recorded, or transmitted. Because the microphone is the first link in the audio chain, it's important to choose the right microphone for the job. When choosing a microphone, you need to consider the desired sound source, whatever the mic is supposed to pick up, and the equipment that the microphone will connect to. The microphone needs to be able to handle the loudness and frequency range of the voice or instrument that you're miking. If it doesn't, your audio might have noticeable hiss, distortion, or voices and instruments might not sound natural. The microphone also needs to be compatible with both the physical connections and the electrical characteristics of the audio mixer, recorder, or computer that it will connect to. If it isn't, you might have problems with noise, low level, or no audio at all. To know how a microphone will work for a particular purpose, you need to check its technical specifications. These fall into 4 general categories. In this segment, we'll discuss the operating principle. The operating principle describes the type of transducer that the microphone uses to convert sound into an electrical signal. The most common transducer types are dynamic and condenser. In a dynamic microphone, sound waves strike a thin plastic diaphragm and cause it to vibrate. A coil of wire attached to the back of the diaphragm vibrates along with it. As the coil moves back and forth, it passes through a magnetic field created by a magnet, which generates an electrical signal that corresponds to the sound. Dynamic microphones can handle even the loudest sounds without overloading, but this also means that they're not well suited to distant miking of quiet sources. Because the sound waves have to move the mass of the diaphragm and the voice coil, they usually have limited high-frequency detail, so they're better for vocals or horns than for stringed instruments. The size of the magnet makes it difficult to make a dynamic mic very small, which can limit your mounting options. In a condenser microphone, sound waves also strike a diaphragm and cause it to vibrate. The diaphragm is mounted just in front of an electrically charged plate. As the diaphragm moves back and forth, it changes the electric field between the diaphragm and plate, which generates an electrical signal that corresponds to the sound. Since there is no voice coil in a condenser mic, the sound waves only have to move the diaphragm. This gives condenser mics better high-frequency detail than dynamics. This makes them ideal for miking stringed instruments, percussion, piano, or subtle vocals. Condenser mics usually have higher output than dynamics, so they're good for distant or quiet sources. Since there's no magnet in a condenser mic, they can be made extremely small, which makes it easier to mount them in tight spots and make the mic less visible. Condenser microphones have internal circuitry that requires power to operate. Usually, phantom power is supplied through the microphone cable from the mixer or recorder. Some condenser microphones can run on an internal battery, but that's less common. Unlike dynamic mics, the electronics in a condenser mic can overload when exposed to very loud sounds. Make sure that the condenser mic you're using can handle the sound levels that the source can be expected to produce. By understanding microphone characteristics like operating principle, you'll be able to choose the best mic for any application and get better results when recording or using a sound system.
Right, let's have a look at microphone polar patterns. Both dynamic and condenser microphones can have different types of polar patterns. The polar pattern of a microphone will determine where a microphone will pick up the sound source most effectively. There are three main types called omni, bi, and unidirectional polar patterns. The most common of these polar patterns are unidirectional polar patterns. There are three different types of unidirectional polar patterns, namely cardioid, supercardioid, and hypercardioid polar patterns. The different cardioid polar patterns will determine the optimal directionality of the microphone. Microphones with cardioid polar patterns are widely used for a range of vocal and instrumental applications when it comes to live sound reinforcement. They provide very good feedback rejection and eliminate unnecessary noise and sound spill that might be picked up by the microphone on the sides. This assists in being able to achieve a good sound mix when it comes to various types of shows, including concerts and theatre productions. Here's 4 illustrations that show what the different polar patterns look like. The first one is the most common out of all of them, which is called the cardioid polar pattern. A cardioid polar pattern has a heart-like shape, and that's where the name comes from. A cardioid polar pattern primarily picks up sound from the front and partially on the sides, with feedback rejection at the back. Most dynamic vocal mics have cardioid polar patterns because they can be used by 1 or 2 vocalists at close proximity with good feedback rejection. The following polar pattern is a supercardioid polar pattern. The main difference with this polar pattern is that it's more directional than a cardioid polar pattern and mainly picks up sound directly in front of the mic and rejects sound from the sides. As a result, sound can be picked up slightly from the back of the mic, but it still has good feedback rejection. Most condenser vocal microphones have supercardioid or hypercardioid polar patterns. The hypercardioid polar pattern is very similar to a supercardioid polar pattern, but has much more directionality. It picks up sound directly in front of it, rejecting most of the sound that might be picked up from the sides. The third one is an omnidirectional polar pattern. This polar pattern picks up sound from all sides and is mostly found with condenser microphones, for example lapel or lavalier mics. Lastly, we have the bidirectional polar pattern that picks up sound from 2 sides. Most high-end studio condenser microphones have selectable polar patterns, making it a more versatile microphone that can be used for many applications when recording single or multiple vocalists as well as instruments at the same time. High-end condenser studio microphones can usually be switched between omnidirectional, bidirectional, cardioid, supercardioid, and hypercardioid polar patterns. In the next video, we'll have a look at microphones with different types of polar patterns. You will clearly see and hear how different polar patterns can affect sound in various scenarios. It's therefore very important to select the right type of microphone for the right application. This video is brought to you by Shure Incorporated.
In part 1 of this series, we discussed the most common operating principles that microphones use to convert sound waves into an electrical signal. In part 2, we learned how a microphone's frequency response affects the sound of voices and instruments. In this episode, we'll review an often misunderstood microphone specification, polar pattern. A microphone's polar pattern defines how it responds to sounds coming from different directions. The polar pattern tells you how the mic should be placed to maximize pickup of the desired sound source while minimizing feedback or pickup of background noise. An omnidirectional microphone has the same output regardless of its orientation to the sound source. Its polar pattern is a sphere. On paper, it looks like a nearly smooth circle. In this demonstration, notice how the sound level remains virtually constant even as the angle between the microphone and the sound source changes. An omnidirectional mic can pick up a group of people sitting around a table, but it can't be aimed to favor one source over another. A unidirectional microphone is most sensitive to sound coming from one direction. A unidirectional mic picks up less ambient noise than an omnidirectional type and is less susceptible to feedback when used with a sound system. The most common unidirectional pattern is the cardioid, which is so named because it resembles a heart. A cardioid microphone is most sensitive to sound sources in front of the mic and least sensitive to sound sources that are directly behind the mic. A cardioid mic has a useful pickup angle of approximately 130 degrees, which can accommodate two talkers or singers, or one user who may not always be directly in front of the mic. In this demonstration, notice how the sound level gradually drops as the angle between the microphone and the sound source changes. A supercardioid microphone has a narrower pickup angle than the cardioid, but unlike the cardioid, it is slightly sensitive to sound sources that are directly behind the mic. A supercardioid mic provides better isolation from room noise and nearby instruments and can be more resistant to feedback than a cardioid, but it requires the user to maintain a more consistent position directly in front of the mic. In this demonstration, notice how the sound level drops more rapidly as the angle between the microphone and the sound source changes. The microphone's polar pattern affects where floor monitors should be placed to minimize feedback. With a cardioid mic like the SM58, the floor monitor should be placed directly in front of the mic stand. This way, it is aimed at the least sensitive part of the microphone's polar pattern. If the same monitor speaker placement is used with a supercardioid microphone, it will be facing the sensitive area at the back of the supercardioid pattern. Feedback will probably be worse than with a cardioid mic. With a supercardioid mic like the Beta 58, floor monitors should be placed slightly to the sides of the mic stand. This way, they're aimed at the least sensitive part of the microphone's polar pattern. This arrangement allows a supercardioid mic to deliver more gain before feedback than a cardioid. A bidirectional microphone is equally sensitive to sounds coming from the front and the rear of the mic and least sensitive to sounds coming from the sides. Bidirectional mics have a very narrow pickup angle. This makes a bidirectional mic useful for isolating one voice or instrument that is surrounded by other sound sources, as long as there is nothing directly behind the mic. In this demonstration, notice how the sound level drops off dramatically when the sound is coming from the side, but returns when the sound is coming from the rear. The microphone's polar pattern affects not only how it picks up the sound source, but also how it behaves in a particular room or with a particular sound system. By understanding microphone characteristics like polar pattern, you'll be able to choose the best mic for any application and get better results when recording or using a sound system.
Right, guys, so that gave you a bit of background on how different types of polar patterns work that can assist in choosing the right type of microphone for the right application. This covers all the important aspects of microphones. There are other types of input transducers as well, but for our applications, microphones are the most important. Lastly, I quickly want to cover some microphone tips and techniques. Microphone applications. The type of microphone will determine the type of application it's best suited for. Would you use a kick drum mic for cymbals or a pencil condenser mic for the kick drum? No. Kick drum mics are designed to pick up low frequencies and need to be close to the sound source or kick drum to work effectively. Pencil condenser mics are designed to pick up the full spectrum of frequencies, but specifically high frequencies. The same rule applies to microphones with different types of polar patterns. Cardioid mics are well suited for vocal and instrument applications on stage to minimize feedback problems. It wouldn't make sense to use omnidirectional mics for stage performances. Omnidirectional mics are more ideal for studio and some broadcast applications since they're used in a controlled environment. As mentioned previously, condenser mics tend to be more fragile and sensitive than dynamic mics. In this regard, it would be wise to use dynamic microphones instead of condenser mics for stage performances that involve sound sources with high SPLs. For instance, vocals and instruments associated with rock concerts. The opposite solution will be applicable to performances that involve sound sources with low SPLs, for example, orchestras. Lastly, we'll have a look at microphone tips and techniques. Firstly, keep dynamic microphones as close to the sound source as possible to get the best frequency response out of the mic. Secondly, microphones react to changes in sound levels. Make sure to set the gain on your mixing console correctly to avoid distortion. The placement of the mic in this regard is equally important. Thirdly, show vocalists how to use mics properly. When using dynamic mics for normal talking or singing purposes, a distance of 2 fingers between the mic and the mouth is suggested. For loud singing, the distance of a closed fist or more should be maintained, and for very soft talking, the distance of 1 finger is suggested. Fourthly, when placing microphones in front of instruments, make sure to keep the on-axis point directly in front of the sound source. This will ensure that the mic gives you the right frequency response. And lastly, use the right type of microphone for the right application to get the best result. Make use of online tutorials and reviews to get the best microphone for your application. Right guys, that brings us to the end of our second session of online sound training that covered input transducers and specifically looking at microphones as an example. In the next session, we will be having a look at the first type of processor, namely mixing consoles. Please remember to like or to follow us on Facebook, Instagram and Twitter, and to subscribe to our YouTube channel for all the upcoming sessions. As always, if you have any questions or comments, please leave it in the comment section below. And thank you. I will see you soon.